Let's see what we got.
So, there are a couple of questions related to tangents, and the first one Samura came across is this one. Ultimately, the class wants to proceed into chapter 3, and that's what we're really going to talk about some tangents on. They have a small bit of it here just for a quick second to give you an idea of the thing. Right? So the slope of the tangent line, very simply, it has some sort of picture, whatever it is, a circle, an arc, whatever it is. And you've intersected that circle or arc exactly one time, right? At one time. And this thing will be called the tangent line. Tangent line is tangent to that arc, right? And again, intersecting exactly one time. So what we're going to say is, what we want to find in chapter 3 is the slope of this line. We mean in the plane, like this, the slope of this. But in our case, we really want to find, the thing we're talking about right here, we want to find the slope that's right against that curve there, right? It's right there, right against that curve, we want to find. That's the slope of the tangent line. This picture is not a tangent line. This is an average rate of change here. And the tangent line and the slope of it, the slope of this line is going to be called the instantaneous rate of change, not average. The two are highly related though. Right? This is the instantaneous rate of change for this curve right at whatever this is called C, right there. But from A to B, there's an average rate of change, how the function got from here to here in an average sort of way. Okay? So, Lou, how'd you get here tonight? Where'd you come from? I mean, Lee. Sorry, Lee, you're over there. Sorry, Lee, yeah.
Laurel.
Where, Laurel? What'd you say? How far away? Give me how far away, approximately?
10 minutes.
That's a time. How far? Not how soon away, right? How far away?
Asking for a distance in miles.
Distance. Give me a distance.
Give them miles.
About
3 miles? 3? Okay. How long did it take you to here? You said 10 minutes, right? He went 3 miles in 10 minutes. Correct? Sweet. Keep going. 3 miles in 10 minutes. Snyder, what was his average velocity to get here? 3 miles, 10 minutes. What was his average velocity?
40.3.
Average velocity. 3 over 10, right?
Yeah.
3 miles. Now this is in miles per minute, right?
Mm-hmm. Yeah. Okay. Yeah.
What's 10 minutes out of an hour?
1/6.
6. So we have miles per hour. 3 over 6, right? Miles per hour. So what was your average velocity? 18. Oh, slow, man. Miles per hour. That's what we drove on average, right? So in other words, for this problem here, here is destination, here is starting point, right? Here is 3 miles away, and here is 0 miles away. So you traveled 3 miles. And how long did it take? 1/6 of an hour. So you divide them, you get the average rate of change, right? You divide 3 minus 0 over 1/6 minus 0, you're going to get 18, you get 18 miles per hour. Did he drive 18 miles per hour the whole way here? No, because he started at 0. And he ended at 0. you're not driving anymore. The unit is 0. So there are locations along the way when you are not driving 18 miles per hour, right? This only tells you what we did on average when you divide like this. When you want to know the instantaneous rate of change, what you're asking is, Lee, when you've been driving for 1 minute, how fast were you going right at that 1 minute? Lee, when you were driving 3 minutes, how fast were you going right at that 3 minutes? That's the instantaneous rate of change. And we don't know the answer to that, right? Maybe you drove 50 miles per hour part of the way, and 1 mile per hour another part of the way, and all averaged out to 18. So the slope of the tangent line is going to be a limit as x approaches a of f of x minus f of a over x minus a. Right? Here is an average rate of change. Function y2 minus y1 over x2 minus x1. When you take the limit as these two, as x gets close to this one, you have an instantaneous rate of change. It's all too soon for this. I don't know why we introduce the first section. All right. It's really for chapter 3. Another way to represent this, though, is as h approaches 0, you would have f of x plus h minus f of x over h. These are the two basic ways to represent slopes of tangent lines. They both say the exact same thing. To get from one to the other, you simply make a substitution that h equals x minus a, and then you can move from here to here, right? They both say the same thing. And that's going to be the fundamental way that we calculate derivatives in chapter 3. They introduce it here just as an idea. Okay? So what's the question having to do with velocity? It's the most common rate of change that you're familiar with. So that's why this one had an average rate of change question. This is what we're talking about. I can't imagine having to compute these yet, though. Yeah, I can compute these yet. But basically, it's going to take on the structures that the three basic structures we talked about already: factor and cancel, the combining the fractions together, and the conjugate problem, right? These things are going to become action that form in chapter 3 as well. You do instantaneous rates of change. Smart? Yeah.
Yeah.
Here I come, look out.
They'll find any kind of
What's that?
string that have the 0 so just go.
That's correct, yeah.
Oh,
So how can it be that, though? What interval was that? From 1 to 7?
From 1 to
1 to 9?
Yeah, 1 to 9.
They were the same, huh?
Yeah, the substitution.
Yeah, it's 0, yeah. Average change is 0.
So you just put 0, right?
Yeah, that's right. That's what you compute, that's what you compute, right?
Yeah, so that's what I mean.
Yeah, that's what it is.